Hi everyone, this is Ms. Mitchell, and this video is going to show you how to do problem number 2 on page 64. So problem number 2 is about the flower pot that is falling from a windowsill that is 25 meters above the ground, right, falling. And the problem asks for two things. Part A, how fast is the flower pot moving when it strikes the ground? So I know I'm looking for my final velocity, not like after it hits the ground, but right before. So how fast is it going right before it hits the ground? And then part B is how much time would a passerby have, right, if he saw the flower pot, and how much time would he have before, he got hit in the head, right? So I have a couple givens in this problem. Obviously my distance, right? But the distance the flower moved, remember, is negative. Okay, so it's negative 25 meters. The convention in physics is downwards is negative and upwards is positive. You also know the acceleration. You can assume it's on Earth, so it is negative 9.81 meters per second squared. And you have one more hidden given. It's not totally explicit, but you know your initial velocity, right? Because the flower is at rest in the beginning of the problem. So your initial velocity is 0 meters per second. Now for the equation. So try to think about what equation relates all of these variables. And the one that comes to mind is A equals the change in velocity, right? VF minus VI over time. And you also have the really beautiful equation A equals 2D over time squared. So let's see which one to use first. I would say if you look at the equation on the left, the issue is you don't have time, and you also don't have your final velocity, so it's good to find an equation that has all of the variables except the one that you're solving for. So this one looks like a winner in this case. So we're going to start with that one. A equals 2D over time squared. My acceleration equals 2 times the distance over time squared. And I'm just going to rearrange it, right? So I'm solving for time, so I want to get it out of the bottom. Got to be strong on your algebra here. And then to get time by itself, get into t squared equals 2d over a. And then finally, t equals the square root of 2d over a. All right. And then I'm going to come up here to save space and just plug in my values. Finally, square root of 2 times my distance, negative 25 meters, that's how far it went, right downwards, divided by, oh, thank goodness my acceleration of gravity is negative, because that will cancel out the negatives. And then if you plug that into a calculator, you should be getting time is 2.257, so I'm going to round that to 2.26 seconds. And let me just check my units really quick, because the meters are gone, right? And you're left with seconds squared on the bottom of the bottom means on the top, and then square root of a square is going to get rid of that square. So this makes sense. That's my time. Okay. All right, now we can find our final velocity, because now we have another piece, right? So now that we have that, we can do the second part, right? And we can use this equation. Makes sense? All right, so beginning with that, A equals VF minus VI over T, the original equation we had for acceleration. Let's solve that for VF. We get T out of the bottom. Okay, on a roll here. And then getting VF by itself. So all I gotta do is do VI on this side plus AT equals VF. It's good convention to always have what you're solving for on the left. So let me just follow good convention. Plus AT, and then voila, you can plug in for values. I'll do it down here. VF equals my initial velocity, which is 0, and that makes it easy, plus 9.81 meters per second squared times time, what was my time? Oh yeah, found it, 2.26 seconds, and then you will get, sorry, I ran out of room, so I'm going to put my equal sign here, 9.81 times 2 point, feel free to do this with me, I have a final velocity, that's a huge final velocity of 22.17 meters per second, so that's going to hurt. He has 2 seconds to move out of the way once he sees it, because that's a pretty big flower pot. And hopefully that was helpful. Awesome.